Okay, so welcome all again. This is the Big Data and Intelligent Analytics Northeastern University course, Spring 2024. And we're officially going to start. We have 12 teams to present. And what we'll do is, in the interest of making sure that everybody gets the opportunity in a sequential order and can prepare for the presentations, we will start with class 1, which is the Friday class. And we will start with team 1, and then class 2, team 1 will go. And then class 2, team 2, class 1, team 2, class 2 will go. We'll do that for the first 4 teams. And after that, it's going to be 5, 6, 7, 8. Okay, so that we can evenly distribute all the 4 classes. So we have class, students from both the sections. So it's going to be 1, 1, 2, 2, 3, 3, and 4, 4. Okay, so Friday class, team 1. You should also introduce yourselves with your names when you come down. Okay. Can you also send me the link to the spreadsheet?
Hello everyone. This is team 1 over here. I'm Dave.
I'm Rishabh.
And I'm Anish.
And this is our project healthcare management, healthcare response system with AI. So what's unique about our application is we take the user's medical history into consideration while giving him drugs, medical. Looking into that, I would say like particular medical drugs will have these kind of warnings. Like if user has like heart disease or if the user has like high blood pressure, you shouldn't prescribe him. So our application takes all those into consideration and prescribes the user a particular drug which doesn't have any conflict with his medical history based on the symptoms provided by the user. So we are starting with the demo.
The first page, what you see while you log in is this registration page. If you are a new user, you're going to register with all your details. And we also have a column that has a medical history. You need to give any type of medical history you have, like, for example, you had a sinus problem from childhood or something like that. So you need to give the details. We also have a zip code. What we are doing in the app is we are locating the nearby store for any emergency kind of thing. If you locate the nearby store, you can go to the store and get your medications or something. So once the profile gets created, it's stored into a Snowflake database. We create a table, and then all the user profiles will be stored there. So we can use their medical history and generate a report further into our app. So this is our homepage. It has all the features we have in the app, and we integrated the services of CVS pharmacies, and also we have continuous report generation. All the features you can see. Then we will go to the text assistant here. You need to put symptoms here so you can get the validation.
So as Anish mentioned, every user will input his medical history. So here I'll just put like heart pain as a symptom. So what our app will do is, based on the medical history, it will give a drug name and the dosage what the user will have to use. And also the thing is, if the user does not give a medical symptom, like if you say like hi, hello, the app will say the text is not a medical symptom. So as you can see here, the user gave heart pain, and So this is this is the drug name which the app suggested, and this is the dosage. And as Anish mentioned that this will, when I click on this link, this will go to the nearest CVS store. So here I mentioned 0 to 115. So this is the nearest CVS pharmacy from which you can get the dosage. Uh, For fever also, it's suggested a drug and the dosage here. So in this, the user can update his details. For example, if he change his address, so I can change the address and the zip code and his medical history. And once it gets updated, it will automatically get updated into the Snowflake, and you can log out as well. And we also incorporated voice assistant. So for voice assistant, since Whisper is very sensitive to noise, since there's background noise, it won't pick up the voice. So actually, this worked in the local, but when you deploy it to cloud, it did not work. And basically, this report thing is based on every user's medical history. Uh, this was the existing user. So based on the medical history, we get two graphs. One is the bar graph, where whatever application the drug name is being suggested to the user, there's a bar graph, and these are the word clouds for all the symptoms which he has mentioned. And here, since there's a lot of data here, a report will be generated, like a doctor report, with all the medical history. Right now, it's generating a report. So as you can see here, the report has been generated with all the symptoms, the drug name, and the instructions. So this is for each day, whichever, like every day which he uses the app and gives a symptom, it will show full report. Also, I wanted to show you this one thing. So the text assist. If I click on submit, so it will the chatbot will say that this is not a symptom. So the text is not a symptom. Now I'll show you. Now they will talk about airflow.
So, so the data pipeline we built for our architecture is ETLT pipeline, and we created like around 4 DAGs. We no, can you scroll down to the architecture level? So, scroll down. So the data is actually gathered from the drugs.com website. and we web scraped around like 12,000 rows. It's clean, like data validation and cleaning has been done, and it's stored in an S3 bucket. And followed by that, we have use OpenAI. We have actually obtained the data in form of paragraphs, and we have to take the symptoms and all those from the paragraph. So we use OpenAI to take those keywords and followed by data cleaning, and then in the last that we uploaded them to the Pinecone. And in the end, we had like around 9,000 rows of data for our application. And we deployed the Airflow, but we didn't run it in cloud, but we ran it locally. We have the output screenshots in the code lab as well. Airflow. So can you go down with? So the DAG over here, scrape drug info, is the main DAG which will scrape all the drug information, and we made two more DAGs over here. The process CSV data and ingest Pinecone data DAG and ingest to Pinecone 1 data DAG to ingest into two namespaces, one for diseases and symptoms and one for the drugs and its corresponding symptoms. We also had like a validation check, like if user mentioned like critical symptoms, the application shouldn't take it and they should ask him to go to an hospital. That's why we had diseases and symptoms.
Thank you.
So yeah.
So what was the source of the data again?
It's drugs.com. It's a website. You can just open it up. It's there. It should be done.
And can you talk a little bit about the testing you've done for this application?
Yeah, can you open the DAG? But I didn't run it in cloud. I ran it in local because it took me around 12 hours to run all the 4 DAGs in total. It's like process. Once the first DAG gets completed, the second DAG will get triggered and so on. It goes on like that. I can show it in my local. I had it open like all the output and all the stuff, so I can show it right now.
Okay.
It's
the
done in
kind
the-
of testing, can you talk a little bit about like what kind
So
of testing?
basically, what happened means when we did like PyTest and PyRank, like very
No, I mean, like, how do you, when you specify a specific disease?
Yeah.
How do you know whether the disease actually is a valid disease? And, the treatment which is prescribed, it's a recommended, the treatment is actually a good.
you're saying when the user gives us symptoms, the treatment is a valid symptom. So that's why we take this medical drug, and it contains why they use this medical drug along with this dosage and warning. In the area of why we use a medical drug, we get symptoms like fever, cold, headache, and all those stuffs. We put those into a Pinecone vector, and we use the accuracy score from the user input and match it with this accuracy score. And we also look at the map the warning as well, warning of the drug and the patient's medical history. While prescribing it. If there's no match, we just reduce to the next drug based on that. Just like we made like a while loop to like while you find like a perfect match, just keep on looking.
Okay, can you just put in some random symptom?
Yeah, he just showed it like it showed up like not a symptom.
You put in something extreme.
Yeah, we do have that extreme thing like for to say like a particular diseases, like if we have like an accuracy score of 90 for we say typhoid or something, we gave these are all typhoid symptoms. And if the user's symptoms exceeds the accuracy of 90, then you tell him like he may be be suffering from this disease and he needs to go and visit the doctor. So we do have that CSV. Can we just take the laptop? Cause I had all those text and stuff
You
to
can do it great. We're having a lot on this. Cool, thank you.
just to show you here.
Next team. Can you please turn off your cell phones?
Hello everyone. So we are from Team 1 Saturday batch. I'm Rasika Kole, he's Aniket Kiram, and he's Sudarshan Dude. So we are presenting Job Fit AI. So before starting, I would like to ask you a question. How many of you think that updating resume is very important nowadays for application process? Wow, that's very nice. So our app is just for you. So during when applications are sent to companies, so they have an ATS system to pass through that. So, but it is difficult for us, for students, for users who are applying for the companies. So for that, we have implemented this app. From when we can see the job descriptions and check the key points, keywords, and we can update the resume so that it is very easy to apply for our applications. And then, as per this, we can get the chance to give interviews and all. So let's see how our app is and how it works.
So I'll quickly go through the demo first. I'll create an account for this. So create an account. Yeah, so we can see three options here. So one is resume analyzer, job fit score, and job recommendation. So in resume analysis, so before that, like we have to categorize the user before like telling him that what are the best keywords are for your profile, and we are doing that based on the resume which users upload. So I'll just upload an resume. I just download it from Git. Yeah, once I have uploaded it. So here you can see that senior software development engineer is the position which that particular like resume for that particular resume our system suggests. So I'll go ahead and like ask for suggestion for keywords. And these are the like skills which basically are like portal gives. So here we have three types of skills: top skills, the skills for the job posting, and the skills like for the resume. So I'll just explain this. So for this particular job role, senior software development engineer, we have searched for the like relative job descriptions in the like portal, and then we come up with an skills which needs to be there in your resume. We are like which will be applicable for that particular post, and these are the like skills which is not present in the resume. And according to the peers resume like review and all, we found that this particular like skills are not present. So once you add this in your skill like resume, your ATS score will go up. So that's what this particular thing like tells us. So going to the second feature, which is job fit score. So I'll get the like sample resume like job description here. So here you can see like by default it gets the like resume which we just uploaded for the categorization. And once I upload the job description, here we can see that 36% is the match for this particular job description. It's low, but yeah, here are some of the like skills which were matched from my resume. Here are some of the missing skills like cloud infrastructure, and like these are the very specific skills backbone JS required for that particular job post, which this particular like thing is saying. And now we can ask for recommendation. Now, what is it? So let it just first complete its execution. Yeah. So if you see here, we have curated these bullet points based on the keywords which were missing in your resume. So once you add these particular bullet points in your resume, your ATS score will also get up, and users don't have to add these points in your like keyword section. So it will be good for the like recruiter side also. And this is like separated based on the experience section. And then there is a like job recommendation part which Sachin will take.
So until now, we have seen like we are getting the job fit score and we are getting the skills that are not in our resume and everything. So now, but whatever your resume is currently, based on that, what are the best fit jobs that are available in LinkedIn? So for that, what we have done in backend, we have extracted the skills in our resume. We have stored it, and we have run a match in a Pinecone vector API. Vector database. So in that, like we are getting the most suitable job descriptions for us. So here you can see we have already got like 20 job descriptions here. So you can look on the insights of the job descriptions and apply links. Links are also given in that. So going forward,
we'll go with the documentation part. And also that like these jobs were like recent, which we
live jobs.
So I'll just go ahead with the documentation part of it. Yeah. So I'll quickly jump to the architecture diagram of it. So initially building our like knowledge base in Pinecone, we have like we got the data from Kaggle and the Hugging Face data set, and we like extracted that data, cleaned it, and created embeddings and stored it in Pinecone. So it's straightforward to upload it in like Pinecone. Going forward, this is the second pipeline we have, which is job recommendation pipeline. Here we have extracted the LinkedIn job, like jobs and other job portals job also. And we are like doing it on an interval basis of 1 hour. This is the Airflow pipeline where the in between the Python code will extract everything and then post it into the like create a embedding and post it in like Pinecone, and at the same time it will also have this in like MongoDB for the use of metadata of what we just grabbed. And like going forward, this is the basic user flow, like what we showed, like coming to the Streamlit, keyword extraction is happening, and then searching for the similar keywords in the peers resume and also in the job description and getting the suggestion for it. Also for keyword extraction, we have like taken like ESI data, like data set from where we got the like we have around like 17,000 plus keywords of like hard skill and soft skill and technical skills also in it. So we are like we are using that data as a like data set for that for to understand what keyword needs to be given the higher importance when it comes to giving the like keyword match for that. And this is the like second user flow for the bullet point which is there. We have used OpenAI for getting the suggestion for based on the current given experience. So yeah, that's about it. Talking about like future scopes and all, like we can, so this particular thing is again niche towards a specific job role, which is software engineer or in terms of tech. Like job profiles like electronic engineer, like civil engineer, or maybe product manager and all of that. We need to have the skills, like skills data for that particular job post. So this is some of the lacking things in the portal, and we have to improve it based on like how well we like structure our data going forward. And again, like multilingual support and all of that things we can like include in it. So yeah, that's it. Thank you. If you have any questions.
Remind me again, like what happens when you do the keyword extraction, like how are you mapping it to the jobs?
So basically, like whenever like there are two types of keyword like scraping happens. One is for the like when you extract the keyword from resume, and we have created an embeddings for the job description. So for that also we have created an embeddings and stored it in Pinecone. So whatever the keywords we get from users resume, we create embedding for that and do a Pinecone similarity testing in that particular namespace and get the job description, which is related to or like more niche towards that particular keywords which the user has.
Okay. And how is the matching happening between the job description and the resume?
So again, the best logic for that is like scraping the keywords from like we have a function to do that, get the two keywords in it, and then we are doing like intersection of it to get the like matched keyword and the rest as a like keywords which is not, and then we are just applying the basic math
I mean, if
formula.
your resume has like hundreds and thousands of keywords just because they just want your resume to be seen,
Mhm.
then the intersection won't really matter, right?
So that is one of the way to full an ATS system to have it like hidden keywords in your resume. Yeah, that is working there. But I mean it's also not ethically good, but it's a way to pass an ATS system.
Then how did you test your system then?
So we have like uploaded lot of like embeddings for the job descriptions, and also we have tested with multiple resumes. So we had 100 around resumes. So we just checked it on based on that, like randomly selected some resumes and got like check for the results.
But how did you make sure that the results that are coming out are usable?
So like we have done a like bit of a manual work here by looking at the what keywords system gives and like finding it into a resume, and we found that it is giving the missing keywords and all.
Okay, cool, thanks.
Yeah.
Next team, please.
Hello everyone, we are team 2 and I am Saigi
I am Ameya.
And this is Shoaib.
and we are presenting NutriBuddy. So I know everyone's goal is to stay fit, but that is not very much possible when we are very much busy in our tight schedules. All we have to do is to track whatever we are eating and how much calories we are burning. NutriBuddy is your companion, which would help you track your calories and know how much nutrition value are you taking in for a day. And how it is done, it is just as simple as posting a picture. Before eating, just like we post a picture on Instagram, you have to post it on NutriBuddy. Let's see a demo for that. This is the registration page for the new user. I'll just put in so you have to put your first name, last name, your email, and the password, which has a restriction to be between 8 to 50 characters. You need to put your age so that so that NutriBuddy would calculate the ideal amount of calories that you should have, your height, your weight. And what kind of activity do you do over the day? It could be what kind of exercises you do. It is heavy or moderate, and according to that, NutriBuddy will calculate your BMI and assign you to a category, and then it will also calculate what should be your ideal calorie intake for the day. We have also given a provision where user can set their own calorie goal for the day. And that's it. You are registered. Then we can sign in using the email address and okay, it is John. Great. So once you have logged in, you have to set in the preferences of your food. Like, what do you like? NutriBuddy would know that what are your preferences for the food, and it will suggest you meal according to your calorie intake. So in order to record your preferences, you can select whatever cuisine you like. Then what are your favorite dishes, like pasta or salad? Yeah, of course, biryani. Moving on, whatever ingredients you love to have most, and any allergies if there are any. And based on it, this information will be then used by NutriBuddy to suggest you a great meal that you would like. Next, how would you keep track of your calories? So what you have to do is just upload a picture here. Give me a second.
So we have created two services. First one is what Saib is showing, which counts calorie based on image. So for that, we are downloading image, and we will be uploading that image. And we are using a multimodal model of Google, which is Gemini, to get the calories that food might be having. And we are also validating that calorie with another API to ensure that the results which we are getting back from Gemini multimodal is aligned with what real calorie should be. For example,
Yeah, so here I have posted the picture of whatever dish I'm having, and then I'll say calculate calories. As I mentioned, we are using Gemini model in the backend, which will calculate what are the ingredients in your dish, and then give the caloric value for each of the ingredients. Again, if you feel that you want to put in your own caloric values, then user can edit the values here as well. Once I click on confirm, it captures my calories. We have also given a provision where you don't want to post a photo, you just want to put in the name of the dish and whatever calories you had for the day. Moving on, for meal suggestions, NutriBuddy would know that depending on your ideal intake, how many calories you have consumed right now. So it will tell you what are your remaining calories for the day, and if you don't know what you need to cook in order to fulfill those calories, then meal suggestions come handy, where we have implemented a RAG that would generate dishes for you based on the preferences that were captured during registration process.
For the same RAG, the data set which is there comes from a 5 lakh data set, which is used to do. I'll just go through it. Just continue with them.
Yeah. It suggested dishes based on my preferences, of course. So and whichever dish I like, I can just say to show the recipe, and it will give me a brief description of how to cook, what I need, and how many caloric values does it constitute to. Moving on, we also have a weekly tracker for to actually keep track of how many food ingredients you had over the week and how are you doing overall. So as you can see, it just captured whatever I put in today, and it will also show me a progress bar where it shows me how much calories are still remaining for me for that day. Also, you can see there's a line chart that gives an overall overview of your week. How did it look like? How many calories did you have on what specific day? And this red line specifically denotes that is your ideal limit. And this is for the whole week. It calculates that from the ideal calories of your whole week, how much have you consumed and how much are the remaining. I can show you a better view. Let me just log in with the demo user that we have. Yeah. So yes. So here, as you can see, if we have given a margin of 50 calories less or more, if you are near to your calorie goal, it is green, and it clearly indicates that you have consumed whatever you should have, and red, it means that you have over consumed, obviously, and that is visible in the graph here as well. So yeah, that's about the demo. Moving on to data sources.
So for the RAG to work behind the scenes, we have used a 5 lakh rows dataset which has 5 lakh recipes. We do some data engineering job by splitting the dataset into chunks and then uploading those chunk CSVs into GCS. Then we pull the chunks from the Google Cloud Storage and we perform some data cleaning and then load the entire 5 lakh rows into Snowflake. For Snowflake to work, so for our embeddings related to the recipe name and the ingredients, we pull in the data from Snowflake and then use Distillbot as our model to make the embeddings and then load data to Python. This is the 4 steps which I explained. We have done it in an Airflow pipeline, and then all of it, while deploying it, we have used 4 containers: Streamlit application, Fast API, PostgreSQL for storing the user credentials, as well as the Airflow is in the separate container. And to tell about the CI, we have implemented CI to make sure that a Docker gets built correctly. So we have kept a Docker build command over there to check whether once the Docker build is done for every push. Also, we have implemented some basic health PyTests, which are a part of the each of the unit testing as well as the integration testing.
Talking about data model, we have 3 data model. First one is user, which stores the information of all the users weekly calorie to capture all the daily intakes of food and to create dashboard and preferences to make sure we are not suggesting something which our user doesn't like. We have 3 different pipelines. First one is Streamlit. It can accept text or image. The text or image will be stored in Google Storage and the link will be stored. We will be using that image to calculate calories that food might be having by using a multimodal model, as I said, of Google Gemini. We will ensure that the calories we are getting is approximately right, and for that we are using a validation API. And thank you.
How are you doing the matching again? Like what is the logic of matching?
For mean generation, right? Yeah, so we have implemented a RAG and we have our own database of recipes and we have stored those embeddings in the Pinecone and different namespaces of dish names and ingredients, and based on users' preferences, the users' preferences are also converted into embeddings. We are using Distillbot embedding model for that, and then we are matching it against our database, like our scraped database, and then we are passing those matched dishes and ingredients as context to Gemini model, and then it generates dishes based on the context that has been passed.
And what was the validation? Is it like how did you test out?
So once we are getting response for Gemini, we are also getting the ingredients that dish is made of, and we have an API the name of which basically gives us nutrition value of all the like whatever we pass it as ingredients. So we are adding all the ingredients which Gemini is returning as and ensuring that the value is in the 20% error rate.
It's here.
It is not yet about.
Okay.
This is the one.
Yeah. So this is the nutrition API and this is the playground of it. So you can see that
3x as.
yeah, it generates the caloric values.
So we are adding up all the ingredients of the dish.
Yeah, and then validating.
But how are you calculating the proportions?
Proportions are also something that we are getting from the Gemini model. We are getting three things. First is the name of the dish, ingredients along with their proportions, and the total caloric values. And based on the ingredients along with the proportion, as you can see, the nutrition API was it is also an NLP API where you just have to pass in like 3 eggs or 4 eggs, and it will generate the caloric values based on whatever quantities and the ingredient you pass in.
Okay, cool, thank you.
Yeah, thank you.
Hello all, I am Akash Suryan. We are team 2 from Saturday batch. This is my friend Anshul and that is my teammate, this is my friend Narayani. Our project is News Nest that summarizes news from various reputable resources and takes it into one place where I can be able to see all the news is curated at a single point that is also in accordance to my interest. The way that this is different from every other news source independently is that I'll be able to see the news from various sources such as ABP News or New York Times, where users always have an opinion that the news sources might be biased. So when I have a centralized system where I can scrape the news from various resources, I'll be able to overpass the bias that is there. And also we have a separate unique feature in our system where I can tell my system what are the keywords that I'm interested in. So let us say that I am interested in Amazon or I am interested in the Palestine protest that is going outside. So whatever it may be, if I am a socialist or if I am a politician or if I am a stock investor, whatever it may be, the keywords that I give in to the system, I'll be notified whether the keyword is coming up in any of the news articles present in our data sources. Whenever it appears, I'll be notified so that I don't miss out on any of the latest news that is out there. I don't have to go and check individual news sources. I'll be able to have it in my own system. So now we'll go through the demo.
So as we know that, as he mentioned that in our system, we are giving users two things, that the top news and users has the interest. So while registering, user can select what interest user has. Like we are registering a new user, what user wants to notify, like if any news comes regarding that, so user will get notified. So let's say we have added Google, Amazon. Once it's done, we'll sign up with that user. Okay. So once it's done, this is our dashboard. So this is news dashboards where user first can see the news. So news, next top news are the top news which are currently happening. And these are the interests which user has mentioned while registering the system. These all are the news. Now in the watch, if user wants to select anything like Walmart or Amazon, regarding the latest news, user can do that. So like we can see here that the latest news regarding the Walmart US CEO, this news we have got. Now watch news from few websites which we scraped from one of website we got the videos as well, the news shorts, which we also captured. So if we can click anything, we can see the video. We can play. Okay, so
Okay.
okay, maybe something. So we'll move to Google search.
This we have implemented using the SERP API that was discussed in the class, where if I am interested in knowing about any news that is available outside, but if I am not able to see that in my system, or if I am going out of my interest, not always that I'll be able to be interested in seeing the news that is in my specific keywords. So if I am interested in knowing about the latest news about Apple or the Palestine event that is happening outside, I'll be able to see it. So this is the event that is happening outside. This we are doing it with the help of SERP API. And by any chance, if I'm wishing to change my interest, then I can go about doing that as well. But yeah, if you remember, before my interest was in technology and entertainment, I believe. Now I'm changing it to sports. And the places that I want to be notified about is cricket now. So if I go to the news dashboard. Yeah. So all the news about sports and the other interest that I chose will be showed up here. And this top news will be always showed to to all the users, but those will be only the top 4 news that is that was very recent. This is to make sure that the users are not missing out on any of the latest news that is happening out there.
And when we click on one of the news, we can get a description that we generated from the news, and we can view the original news article. Also, we have a feature for sending out notifications. For this user, currently we don't have any notifications. I'll log in with the test user.
We do not have any notifications because notifications work in such a way that now if I enter cricket as my interest, whenever a new news article comes about cricket, then only I'll be notified. So we already created a user so that we could show a demo.
Yeah. So in this, the interest is Amazon. So as you can see, whenever a news feed is there for Amazon, we are getting notified for this user, and we can click here and view the original news article. Moving on to the architecture diagram that we have implemented. Sorry. Yeah. So what we have is we have four news websites as mentioned here. We are scraping the news from those websites, embedding the titles for the news, and checking it against our vector pinecone database to see if there are any duplicate news. If there is no duplicate news, we are moving on to put the scraped data into GCP bucket, and then we are using that file to in our cleaning script to clean and then pass on to our keyword extraction file, which is extracting the keywords which are from the title to get notified about the news, and then we are finally loading everything into our Snowflake database. The next flow is when the newses are loaded. So we have a DAG called publish, which is a cloud function which is called every 15 minutes, and it checks our Snowflake data warehouse where if we have like any new news there, and we just pass for all the keywords, we are passing it on our Kafka stream, which is going on to our subscriber, which is constantly listening to that stream and updating the user notifications in MongoDB. And the last flow is where the user is interacting with the app. The user is interacting with the Streamlit UI, which is first getting authenticated with MongoDB, and we have a connection with our backend API, which is interacting with Mongo for notifications and with the warehouse to give us news. The business interaction is pretty much straightforward. User creates a profile and he gets the news feed based on like the summarized news, watch news, and the search, which is using SERP API. The tasks are collection, processing and loading, extracting keywords, Kafka for streaming the notifications, Fast API service to handle connect everything together. DAGs are implemented for web scraping and loading the data, and we have hosted everything on GCP. For Airflow, we have 5 tasks total. 4 are for web scraping, which like all the topics in those run in parallel. So the first column here is for scraping, the next one is for cleaning, the third one is for extracting keywords, and the last one is for loading the data. And it's been running on cloud for past 2 days. The next is
Now, in the data as a service, we are storing data in Snowflake, MongoDB, and GCP buckets. So the all raw data and clean data we are storing in bucket. And after creating external bucket, final data will be getting stored in Snowflake. In a model as a service, we are using OpenAI for the embeddings and NLTK spatial library for extracting keywords. These are the data storage are screenshots which our files are stored.
This is the Streamlit application UI that we just demoed. And then can you move on to the code snippets?
These are some demo code snippets. We have implemented PyTests for the Fast API service, and we are running those PyTests. For cloud deployment, we have deployed all the services on Cloud Engine, and we have Cloud Functions running for all the tasks that are orchestrated via our Airflow pipeline. For CI/CD, we have a cloud build.yml file which like triggers a build on our GCP cloud build function. And for these are our future works and the references that we have used. Thank you.
How are you maintaining the freshness of the news?
So our pipeline is constantly running for every 15 minutes, and it is scraping the data from all the news sources. And we have our vector pinecone database, which has like 2 namespaces. One is yesterday and one is today. And we are like swapping it each day, and we are like clearing out the old one.
So you only get
the fresh
what was there yesterday.
This is for like avoiding duplicate news. So like,
no, but we are doing it on a daily basis. Like you can only see yesterday's news.
No, we can view all the news, but it always comes in like a ordered by the date and time.
Okay. No, but how frequently will the old news get removed if it gets removed?
It will not get removed, Professor.
It is in our warehouse.
So to be more precise, if I extracted my data yesterday from news sources, that I'll be storing in yesterday's pinecone, and then if I'm again doing it today, that I'll be storing in today's pinecone. And for the news that will be upcoming tomorrow, both of these will be stored in the Snowflake. The Snowflake is the final data warehouse that we have that we are integrating with the Streamlit. This pinecone, we are just using it to filter out news that are not already present in Snowflake. So instead of going into Snowflake and querying the title directly or querying the description, we are using a pinecone database so that we check upon the vector similarity, so that we filter out on the news that is already present in Snowflake. So only after pinecone filtering, the news will be stored in Snowflake. From Snowflake, we will be displaying everything to Streamlit application. In Snowflake, all the unique news will be present.
Okay. How do you avoid duplicates?
So we are doing a vector matching, and we get the top K values, and if the score is above 0.85%, we are tagging it as a similar news.
Okay. Next team, please. You're already team 4, so which is good velocity. And also the acceleration. We are close to 7 o'clock. It's about 20 minutes, so we will be getting close to 9:30. We'll see how we do. So you want to take a break, a 5-minute stretch, quick 5-10-minute stretch break after 2 more teams. So we'll be at like the midway point, and then we'll see if we're going to get the break and then do the rest of the presentation. So this is team 3 from section 1.
Section 1.
Okay.
Good evening, everyone. The system that we have built for the final project is Job Match. What Job Match is basically, every day we have to, if you have to search a job, you have to go to different portals. You have to go to LinkedIn, Indeed, Glassdoor, and whatnot, right? So what job match does is it integrates the latest jobs from, it scrapes all the latest jobs from these different portals. For now, we have 3 different portals, that is LinkedIn, Indeed, and Simply Hired. So we are fetching those jobs every day into our system, and what we are doing is the user just has to upload their resume. That's it. Once that is done, we are providing the top 10 similar jobs to the user based on the data set that we have and the resume that is being uploaded. So we are doing this matching with the Pinecone Vector DB. But we'll first proceed with the demo and we'll show you the architecture that we have.
Good evening, everyone. I'm Rachna. So this is our application where Streamlit for the front end and back end we have Fast API. We have a login and sign up page. We already have a set of users, so I'm going to skip the sign up. So we have 4 dashboards. The first one where the user can upload their resumes. We have multi-select. But for now, I'll show with one resume. This is a sample resume that we found on the internet for a financial analyst. So let's go ahead and upload the file. Once it is uploaded, once you select the file, it will ask if you want to upload, ask for confirmation if you want to upload. So the uploaded file is stored in our S3 bucket where we then extract the text and then clean it and store it back in the S3 bucket. Now, based on the resumes that I have, I can go and select which resume I want. So let me select financial analyst resume that I just uploaded. You can also view this resume that you have uploaded. So based on the resume that you have selected, you can get the top recommendations, that is the top 10 jobs.
So the top 10 jobs basically are working for using a cosine similarity function that the resume was embedded and all the jobs were also embedded and stored in Pinecone. So we did a cosine similarity and based on using Bird, we got a match score that is displayed here.
So as you can see here, we have top 10 jobs where you can see the match percentage and the company and the location. And you can also see from which source you got the job. Let's open one of them. You can go here and apply to the jobs. Next, based on the resume that you selected and the most matched job, we can get the missing keywords.
So this part is being done by using a GPT 3.5 call. We have fed the job which is totally matching the most resembling match job as context, and we have given the resume, and they both act as context, and we will be fetching the missing content that is not there in the user's resume, and we are suggesting that so that they can work on the resume better.
Yeah, so based on the missing content that you get, you can go ahead and update your resume as well. And we also have analytics dashboard where we have made some analysis based on the jobs that we have scraped. So the first one is job density across the map. You can see from the scrape data that the job count for California is more. As we all know that tech hub is Cali, California, Texas, and New York. So the counts for these places is more. Next, we have also made an analysis on the count. So for the particular title, how many jobs that we have. Also, for the jobs, we can find the minimum salary and the max. We have plotted box plot for minimum salary and maximum salary. And that based on the type of employment, that full-time or contract, we have a pie chart for that.
Next we go to architecture diagram that Ritesh will cover.
Yeah, so the architecture that we are following is that, as Muskan mentioned, that we are using LinkedIn, Indeed, and Simply Hired as 3 of our platforms. Earlier, we were using only LinkedIn and Indeed, but now we also include Simply Hired to get more and more jobs, especially the more the data, the better the results get, right? So initially, we are loading these data and we'll be loading the data into S3 and we'll be doing validation on the data using Pydantic and those jobs that are scraped. Those will further get embedded using the Hugging Face transformer sentence transformer bot, and those embeddings will be stored in Snowflake. After that, as you can see, the user we have a user. A user can is interacting with the Streamlit dashboard. In Streamlit, we have the user will be able to feed their resume, and the resume will be embedded again. First, we'll be fetching the text using PyPDF, and then the text would be embedded, and those embedded jobs. The embedded text will be doing a similarity search using cosine similarity, and we'll be getting the top 10 jobs. And also we have given user authentication using MongoDB so that the resumes will be mapped to based on the user. So that's our flow. Muskan will further explain the flow part.
So we have a scheduled pipeline for all the 3 job portals, that is Indeed, LinkedIn, and Syntired. Every day at 11 p.m. we are scraping the jobs. We are validating the jobs, and embeddings are done, and then loading of those jobs are done into Snowflake. Yeah, we are pretty much at 2,000 some jobs right now in our system. We have also implemented continuous integration data.
So for each of the push that you make to main branch, then we have a build trigger. As you can see, we have some pending, where the application will be containerized and pushed directly. Yeah.
Okay, thank you.
That's all from my side.
So what are you extracting from the resume and how are you doing the matching for the jobs again?
Yeah, so we are extracting the entire text from the resume, whatever the user has, and the jobs that we are scraping from the job description. We are doing a matching with using cosine similarity between the keywords that we have. So the more the number of keywords that match using word, the higher would be the score.
Okay, and how is the jobs kind of coming in? Is it in real time or are you doing it in batches?
Every day at 11 p.m. we are scraping the jobs from all the 3 portals.
How do you avoid duplicates?
So in Snowflake, we are not using exactly copy into command because that is not going to make sure. So we are using merge into. So it merge into what it does, it makes sure that if on the job ID we are doing it. So if the job ID is already present, it won't insert. It will just update.
Okay. And how do you make sure that the job was not filled? I mean, like the job you had an ID from yesterday. So if the ID is not there today, the job, are you looking at that?
For Indeed and Simply Hired, there is no, it's not visible on their platform itself, but on LinkedIn it's visible. So we are doing that on everyday basis again. But only for LinkedIn that is happening, and we are removing the jobs.
Okay. I didn't really get the matching aspect very well. I mean, when you say you're having like 4 or 5. You're just doing like a percent similarity on the scrape data, the Indeed or LinkedIn and the resume. That's it for that.
Yeah, so because like most of the content in the resume, basic skills section or whatever, that data along with, since we have so many jobs, so if we are doing similarity search with all the vector IDs, we are able to see that we are able to get good results based on that. We earlier thought that we could like just limit it to skills section of both the job description and the resume, but the score was already good that we didn't feel the necessity of doing that.
Okay, cool, thank you. Next team. So your team 3 in section 2, right? Yeah. We're going to take a break after this presentation. Okay.
All right. Good evening, everyone. So right now we're tracking, as you see behind me, San Francisco's crime rate. How many of you have been to San Francisco, want to go to San Francisco by show of hands? Thank you. So you might know that visiting that place, if you're visiting, it is a havoc because there's crimes every day. Someone will carjack your car, someone will steal whatever you have. So it's really important to plan ahead to make sure you don't carry belongings. And if you are in a car, you take them with you and don't leave it. So something we did was we built an app basically to track what the crime is, give the power back to the user about what's going on so that when you leave your house, you know if you need to take your bags, if you need to leave at home or what you need to take. The demo would be given by Ekta.
Hi everyone, I'm Ekta. I'm going to show you the demo for our app. So basically we built this crime tracker app for San Francisco, and we have a sign up page here as well. And since we already have some few login credentials, I'm going to go ahead and sign up, log in here. So yeah, login was successful. And here we have, firstly, we have a crime dashboard. This loads fairly quickly for a data set of almost 1 million records. So here we have the crime dashboard. This is kind of built for users, people from SF who would kind of want insights on, what day of the week is the most riskiest to go out, or what day of the week, you have to look at your cars. Also, like, it provides insights to a lot of other stakeholders in SF as to, the analysis from the previous years and what locations are pretty much unsafe. So here to talk about the first one, we have like incidents by the day of the week. This shows pretty much that Friday is supposed to be the one that has the most crime incidents that happen. It's almost 129K over the last few years. We have data from almost 2018 to 2024, and then I have filters here as well, which we can edit. So here, this is going to show incidents only from all the years except for 2018, now that I edited this. So in terms of day of the week, we have Friday being the most crime incidents one, and then moving on to incidents by year, we have 2019 to be the one which has the most. 2024, we're just almost not even halfway there. So 2020 was supposed to be the least one, and pretty much COVID says that all. Here we have top 15 incident categories. So here we see larceny theft being the most, the pretty much most category, majority of the category that we see from the top 15 that we have here. Talking about the interactive bar chart, again, we see larceny being the most, and probably residential burglary being the least out of the top 15. Just to show you a few here, a few filters, we have, the report status of what incident was open. So over here, we have open or active. 81% of crime incidents so far are currently open or active and they haven't been resolved. A very few number of them have been resolved so far. That would be 18% and pretty much 0.2% here. Yeah, just kind of showing, yeah, here this has reflected, and then we also have a yearly crime trend. I think I removed the 2018 from here, and then again, we see the same range. We have the top crime locations that would be pretty much useful for someone to look at. What locations are pretty much unsafe, and then we have the incidents by police district as well. So it kind of reports on what police districts had the most number of crime incidents happening. And then here we have the monthly crime analysis. So this kind of like we can hover on these and then see which one kind of had the most. So October 2023 had 4,000 crime incidents happen in SF. So this is pretty much about our crime data dashboard. We cached the data because we had approximately 1 million records here. Moving on, I believe Parth is going to give you an overview about this map.
So hi everyone, my name is Parth Kalani and I'm going to introduce you to the heat map. Now you would say, what was that dashboard for? So there are many use cases wherein the people who are more highly intellectual, like interested in the data, they can view the dashboard. But for those who are like, okay, why should I watch the dashboard? Or let's say I'm not a government official who wants to see the dashboard and be like, okay, let's make decisions. So I can come to this dashboard and be like, okay, I have some different metrics that I can select from. And here you can see there's a chart, bubble chart. This is an average of all the crime rates that has happened in the past years, like from 2018 to 2024. And here we have highlighted 15 major crime areas wherein the crime has happened on the particular metric. So what the metric defines is, if you go up on the top, you see days of the week. What that defines is that from Monday to Sunday, we have the slider here. You shift the slider and you see the data, the heat map changes. If you shift the slider again, you can see the different spots which are prone to crime incidents on those days. So you can prevent your going to that location. So be very aware. You can see weekends we have more number of crime hotspots, and those hotspots are quite red at each of these locations. So these can be very important. And not only this, we have time of the day. So it can be morning, or afternoon, evening, and even night, that you can track these metrics. Also, there's one more section we have added is holidays. We can take Washington's birthday, Good Friday, Independence Day, Christmas Day. All these locations define where the crowds have been more prominent and are prone to crime incidents. And there's also year and category for different types of crime incidents. So next, I'll hand over to again Sumit, and he will go over the AI help that is going to help us.
Thank you so much for that, Parth. So one thing my teammates wanted to mention, why did we focus so much on that? You could see a trend pre-COVID, you could see a trend drop during COVID, you could see it picking up post-COVID. That gives the authorities an idea of what's going on before, between, and after. Now let's look at this. We're all students, right? And people party. How many of you think calling 911 is the right thing if you want to do a noise complaint? Anyone? It isn't. So over here, we've trained our model on the penal laws. We've trained our model on the criminal laws. So let's do something. Very quickly. There you go. It is not recommended that you do that. Except this, if there is, we have, as I mentioned, we have trained this model. Again, if I just want to, you saw all this analysis, right? So let's do something. So what this is doing is, you saw a million records that we just told you about. It's going to give you a brief summary of that. You don't want to go through those graphs, don't do it. Come to this chatbot, there you go. You have it. You have a decline over the last year as well. So we have different models in this. Again, we have trained it. We're using SERP API as well as generating our own query, which then goes to Snowflake and gives us the results. I would then like DY to then carry over.
So as we have limited time, maybe I will go through the collapse quickly with give you like a whole picture of our project. So let me directly jump to this step. So about the data source we are using, we use the San Francisco data portal. It's provide a lot of public data actually. And what's cool about it is that it will automatically update at 10 daily, I think. So we set our first data pipeline Airflow to run at 10 past 10 in the morning. So it will get the latest data and store that in Snowflake. And also this how we pull the data from the API. If you are interested, you can take a look at something. Yeah. And then this is our project architecture. So you can see like the yellow bar is like the two pipeline for our data resource. So one is from this one is SF data port, and this one is the knowledge base that we use. It's actually 3 PDF files. So these two data pipelines will run daily, and the SF data port will update every day. And when we upload some new knowledge base file in the S3 buckets, then it will upload to the Python, and then we'll provide some basic knowledge for the OpenAI model we are using. And also we pull that all on the Docker and run really fine. Okay, so time is up. That's it. Thank you very much.
Any questions? The questions you were asking, where is the answer coming from? Is it just
we built as there was mentioned, we have built a knowledge base as well. We have scraped through PDFs of crime laws, penal laws. We have also used
of which one? I mean,
of right now of California state, because it is San Francisco.
Yeah.
And let's say you are a San Francisco resident going to Boston as well. So there's a SERP API that would help you in that situation as well. For future scenario, we would then expand it to different states and include different PDFs and different laws to the state.
Okay. And how did you test your system?
So basically, we created some data analytical pipelines. So we did that on dbt, and we also implemented Airflow and Docker. And on GitHub, we have a block of code that will constantly generate a Docker regularly, I guess. And that's how we are testing our code.
And the knowledge base that we have created for the chatbot, if I ask a specific question, we can see in the backend, as we did in our class as well, it goes to the knowledge base and gets the data from there. And if it does not find it there, then it goes to the SERP API. There is also the data that we're pulling from the million records. So in future, we also want to do that the OpenAI generates the query on its own, goes to the database, does everything. It's basically an automated pipeline that is almost done, and that is what would take another day for us to implement.
Yeah, we were almost there. Yeah, we went it for future scope. That.
I wasn't very clear, who the user is for all your analytics, how do that?
So the dashboard, we can say the major user you could say is the government officials like police department, mayor, who can make some good decisions, because usually people like us, we don't go for the charts. But the heat map is for the users, like those who want to actually check out which are the areas which will be prone.
The static data in Snowflake, or where is it?
No, it will be constantly updated every day. Airflow and
Airflow. Yeah, we will update every day in the morning.
In the morning, yeah. So data is updated on the website by 10 p.m. PST, and we'll update it by the morning.
Okay, cool, thank you.
Thank you, sir.
So we went through the first 6 presentations. Good job, guys. Now we're gonna take a quick 10-minute break. It's 7:21. We'll keep the session going. Okay, we will just do a pause, and then in 10 minutes we will start with the next team. So if team number combine them, team number 7, which is technically team number 4 from group 1. So if you guys want to settle in and get ready, that we appreciate it. So that when we start out, we can start with the next 6 presentations. Okay, cool. So let's take a quick break and come back.
After some time, because now the content has getting yesterday the person tried you. They won't be quickly able to use it because now wait for more than normal days that I am so they
I sent you.
Came to us and we know your project. They cannot do that. No, we were also there.
No, I didn't see that one. I just focus
I'm gonna say, because we have to work on a similar note. So I look forward to collaborating with them. That's what.
the thing is, we for different batches, we didn't know what to do.
Yeah.
So I guess that's why we approved both of the.
It's also a different.
Lower the grades.
We are the president. We are not a secretary.
Create a diagram. You will take great segment to find out. What is the mean for weekly? Sorry.
What is the least in that? Sure, sir.
अरे आ जाए अभी टीम में प्रेजेंटेशन देना अरे चेयर
After presentation, over you got a pencil.
After the presentation, I was literally feeling sleepy. That all the presentation is going to break. कुछ भी हो सकते हैं एक तो ऐसा भी कि 2 दिन से रन हो रही अभी 4:30 को लास्ट कमिट करके चला बट वो प्ले वाले सारे
At that time,
No, I Just move your chair.
Yeah, also we had 6 presentations and we'll have the next 6. Good job on the first 6 and we'll continue the acceleration and try to see if it can be done by 9:30. Okay.
Hello everyone, we are group 4. I am Ritija.
A little louder.
And our project with City Reach. So we built this app to enhance users' library experience, digital library experience. We want to make book recommendations to users based on their user history and the books that are available in the library. Imagine if you go to the library and the book you wanted is not available. What if the library suggests you? What if the library suggests you books that are actually available and are based on your preferences? So this is what the app is. I'm gonna register with a new user. Now I'm gonna log in. So for a new user, you'll see a chatbot which will ask some information from you. So it asks you basic book features, what you like, or what the genre you like, or the mood of the book that you like, themes of the book. Let's say I like complex books, I like fast-paced books. So based on this data, you'll get some book recommendations. So there are some book recommendations. Let's say I've read some of these books I've already read. So I can add these books to my already read tab. And then I can search for new books. And then I can add these books to, let's say, I want to read a book. I want to read this book. Then let's say so what I'm doing here is I'm building a user profile so that as a new user, you might have books that you've already read or want to read. And oh, I've already added this book. So now we can go to user dashboard and it will display all these books that I just added. You can add user rating, your rating for the books that you've already read. And I can update my journey that I've finished this book. The books that I wanted to read, I've started reading. And based on this, you'll get new book recommendations. So I can refresh my recommendation. So every time user updates any of these lists, they get new recommendation.
And also,
We have the audio feature.
Not only as the best concise introduction.
Anirudh will explain the architecture.
so this is the architecture diagram of our project. We have basically three data sources. One is Seattle Library, one is Goodreads, and one is OpenAI. So Seattle Library API is used to generate the inventory of the books. Goodreads is used to get the reviews, genres, and also the ratings of the books. And also the languages are translated back into English using Google Translate. Then this process runs once every month. We are doing this because we have noticed that the Seattle Public Library refreshes its inventory once every month. We have created a Airflow DAG that does the data extraction part. All the data is stored in Snowflake. Then this is the user, how the user would log in. He would be able to see a student dashboard. And basically what happens is once the user is created, and as she demonstrated, a user profile is created, and this user profile and the book profile is stored in Pinecone vector embeddings using absurd logic. So we have two profiles, user and book profile. And the recommendations that are generated using cosine similarity search. Also, the audio which you listen is generated through Google text to speech that is stored in S3, and it is fetched from S3.
So now you might have a question about how we are generating the profile and how we are recommending some books to a user. So we are creating two different profiles. One is the book profile and one is the user profile. So we already have like different book data from Goodreads, and like we are getting some additional features through OpenAI that are not available on Goodreads website. So they are like mood of the book, themes, and what is the plot complexity of the book, and etc. Now for the book profile, so let's say we have a book, it has some different features. So we have assigned different weight to each of the features. So the feature that is more important in generating a book profile, that has been given more weight when compared to the other features. And once we are creating that book profile in a vector format, we are saving it to the Pinecone. Now talking about the user profile, you saw in our dashboard, there are three different kinds of books the user has, three different flags. One is the book that the user has already read, one is what he is currently reading, and one that he wants to read in the future. So all this have different weightage assigned to when we are creating the user profile. So let's say if a user has already read a book, the weightage for the vector for that particular book when generating the profile is higher when compared to other two flags we have. Now you also saw that user can give a rating to a book he already has read. He can give a rating from 1 to 5. So there might be a case like the user read the book but he did not like it, and he might give it a low rating to the book, and he won't want to get recommendations for such books. So we are deciding weight based on the ratings we have the user provides for the book. So more the rating, the higher the weightage for that particular vector.
Then we create cumulative profile for the user, and then we use the cosine similarity to match the book profiles we have in Pinecone, and we give the recommendations. Also, we while recommending, we make sure that the book is currently available in the library. So it's not a book that's out of stock, so that the user can just go and grab it from their public library. Thank you.
Like what actually happens like when the user creates, like what are they actually providing?
So when user creates, so they can get an interactive chatbot. They can provide what kind of books he wants and what kind of books and complex book. If it's a there is certain user base that reads book that are like a smaller length, bigger length, all those information, and then there is a user dashboard where he can add the books he have already read and what he's currently reading and what he wants to read in the future. So we take into consideration all those books and build a user profile.
And how are you doing the recommendations? You're just doing cosine similarity, or like what are you doing?
So right now we are doing cosine similarity with the book profile we have. So we are doing content-based filtering, but in the future we can add collaborative filtering to get more precise recommendations for the user.
Okay. And how is the cold start problem solved? Like how are you trying to solve the cold start problem? Like if the user comes in the first time and
Yeah, so if the user comes in the first time, so we have asked some different questions to the user. So based on those answers, we again have to create a user profile, but it will not be based on the books he has already read or the personalization part. What he answers to the chatbot question that generates a user profile, and it matches to the book profiles we have.
We have a book attribute table which stores the attribute for each book. So based on the chatbot interaction, we match it to the book attributes and then give the first 5 recommendations.
okay. Well, thank you. Next thing, please.
This is Team 4. I'm Ria. I'm Nidhi.
I am Deepa.
We want to take you through our application, which is Binge Watch. So we have noticed that there are multiple platforms and a lot of data were present in those platforms, but there were nothing there which have all the aggregation of content. For example, I'm a user, I want to watch something and I'm not very sure what I want to see. I have a little bit of idea what I want to see. So that would be my first obstacle, which we want to solve with Binge Watch. And second, if I know what movie I want to watch, but I'm not sure in which platform it is present, then I have to basically go in every platform and search for it. So it is a large digital era and we have too much content in it. Just to resolve that problem, we have come with Binge Watch. We'll start with creating an account. So here we're creating a user account and let's log in. Yeah, so once we log in, we have our input query where we can ask, when we can tell what we want to watch. So I want to watch maybe Traveler. And you can also pick a type. Movies. So when I hit enter, it's going to recommend me the movies based on time traveling. So I can choose so what I like, and I can watch the trailer as well here for each movie, and I can see that which platform it is available on and when it was released, the cast and everything else.
and a specific user can like or dislike it as well. So we are storing the history of the user which he's liked in the history page.
So here we will see the list of movies that was movies or TV shows that was liked by the user. So we also can do the same for TV shows, and we can give a speech input as well. And we can even pick the movies based on like the keywords. I mean, by name, we can filter these movies as well. So it's going to give me all the input and which year it was released and all the other data as well. So this can be done again for the TV show also. So yeah, here we're going to get all the data that we have asked for. Now, let us
So for our stakeholders, the primary stakeholder for our solution would be the subscribers directly who are viewing it, and the secondary stakeholders would be the content curators or the marketing team which are targeting them. We'll go to the data source.
With respect to data source, we have procured data from multiple OTT platforms, which are primarily, for now it's Netflix, Prime Video, Hulu, and Disney. So to make sure that we have covered most of the movies. With respect to this problem statement, the data source we have procured is pretty large, which we can see it's unique 23,000 records. And apart from that, we have also scraped the web links for the trailers of the movies so that we can give more better user interface, user experience when it comes to the Streamlit front-end page.
So we'll go over the data enhancement. So we have gotten the data, the publicly sourced data, and we have scraped the trailers and other metadata. And now with this data, we also get the description of each content. So for each TV or movie show, I have its description summary. So we have generated really niche keywords, very specific keywords based on the description that was provided. We've passed it using, we have generated that using the OpenAI model. So it makes our system even more robust. And then we have cleaned the data and then stored it in Snowflake. So this is our overall architecture. Let me go through the data architecture. So we have an Airflow pipeline that triggers the data collection and scraping of the trailers and thumbnails and such. We store it on Google Cloud. We perform the keyword generation, cleaning, and everything. Post that, we store it on Snowflake, and we also embed it into Pinecone. And
so I'll go to you to the recommendation architecture. So basically, user will interact with the Streamlit, and from Streamlit, the query will be passed to LangChain via fast API, and the OpenAI chat model will process the data and will give top 16 recommendations. And we have used the cosine similarity as well as RAG model just to see the result, who is giving us the better result. We'll go, these were the deliverables, and now
so for data pipeline, as I explained, we have an Airflow that's going to trigger all these tasks. And so right now we have the data set that is for this POC, we have data set from up to 2021, but we'll be scraping the latest releases from websites like Flexible and a couple others. So yeah, and so we are storing this to Pinecone. The databases that we have used for vector database, we have used Pinecone.
So I'll take you through to the Pinecone vector database. So basically, we have asserted movies and TV shows, and for that we have created an index bot, and we have two separate namespaces, one for movies and one for TV shows, which you can see on the screenshot. So we had in total 14,783 data, which were again divided in two different divisions, which we were querying via Streamlit and getting the answers. And the second warehouse we had is the Snowflake. Snowflake contains the processed and clean data. So it contains two main table, movie row and show table, and third is the SQL database. Basically, it contains the user related data, which would be username, password, and the feedback related data is also in the SQL database.
So we are also taking speech input for our application. We're using Whisper AI API for that. And yeah. Okay.
Yeah. So to get the top 16 results, we already had the preprocessed and clean data. We are again taking the CSV. What we are doing, all the columns of CSV, we are making a sentence of those column and inserting it into the metadata field of the Pinecone, and the sentence in the metadata is then changed into vector form in the vector column, and then we are creating the index. And for the semantic search, we are using LangChain's data frame loader to process the data and load the data into the index. We are using OpenAI embedding, which is a language model, to get the similar results. And we are using cosine similarity in this case. And then we are retrieving the data and getting the result based on the accuracy of the vector, which is already in the Pinecone. And we have implemented the RAG implementation. So here we are using retrieval QA chain, which is made up of using a language model and vector store. So whenever a user is inputting a query, it is going into a retrieval QA, and we are getting the results, not top 16, but some of the results. And we notice that these results are more better as compared to the cosine similarity, which we were getting before.
We have deployed our application on cloud. As of now, we do not have any load balancers, but should there be traffic on our website, we plan to implement that as well. And we are going to, and we have performed unit tests, and we have integrated continuous integration for our testing. And so these are some of our references.
We get some notes from specific sites, right?
Yeah, I mean, the initial data set we have from Kaggle, but the metadata related to that we have scraped it from the movie database.
Okay. And how is the matching happening again?
So we have the descriptions for each content. So we are creating more specific keywords. So let's say in the description it says that this is a movie based on a novel, based on the world famous novel, blah blah blah. So it's going to generate then based on novel, and then by this author, all those other metadata that the keywords that are required, and we are forming this entire thing as a sentence and upserting it, and then the input query is also like vectorized, and we are performing semantic search on it.
Okay. I mean, as the user uses your system, anything happens, or is it just like a static?
It's a platform for them to see the data that is available. So it's just consolidated platform as of now. But we plan to integrate the user feedback as well to provide more personalized recommendations.
Okay, thanks. Yeah, next thing, please. Your team 5?
Team 5.
So hello everyone. So we are team 5. I am joined along with Shikhar, Aditya, and I am Shubh. So our topic, our main project is Poclias. So what basically is Poclias? Poclias is AI assistant for doctors. So what we are trying to do is we are trying to help doctors make better decisions and like help them make better decisions and increase their improve their patient outcomes. Before moving to the demo, I would like to state a quote here by one of my favorite chess players, Garry Kasparov. The future belongs to humans and AI working together. The intelligence of human beings and AI can solve world's most challenging problems.
So this, as you can see, this is our platform, and initially we would be creating up a user. So let's say in this condition, we are creating a user named Shiv. So you can see that account is successfully created. Now we will be logging in. So this is the first page, that is the patient management page. So when a doctor logs in, so he can have a look over like which all patients are available, enter a patient detail, and even can edit the patient details as well. So let's say we would be entering a specific patient details. Aditya, an insurance provider, let's say is Blue Cross. And let's say he has any of the medical history which is related to that of heart disease. And medication, he is not taking anything currently, so we will be saving that detail. So the detail is been saved. So we can view the patient detail from here. So this is the detail, and also we can edit the detail from here. And now moving on forward. So this is our AI assistant that would be helping in the healthcare. So the main idea was to record the conversation which is happening between the patient and the doctor. So like over here, we would be just showcasing a recorded audio.
Good morning. How can I help you today? Hi, doctor. I'm Emily Garcia. I've been having severe abdominal pain and diarrhea for the past few days. I think, can you tell me a bit more about the medical?
So now I would be uploading this audio. And it would be generating entire summarized output from the same. So this is first the transcribed audio, and it has been converted to text. And after that, a summary has been generated along with the name of the patient, medical history, and all the symptoms which has been taken out of the entire conversation.
Medical history, diagnosed with Crohn's disease 10 years ago. Background, under a lot of work-related stress. Previous medications, mesalamine for managing symptoms. Test result.
So here the doctor, if he finds anything which needs to be changed or any other crucial information which is not there, so he can just add it over here, and I'm just entering the patient name over here. And would be saving it up. So for converting text audio to text, we use Whisper AI, and it has been
Emily Garcia.
And it has been passed to that of the OpenAI in order to get a summarized output from the same. And we are storing it in S3 in order to generate further analysis for the patient. Now, as you can see over here, for the medical image diagnosis, a doctor, if he is given any kind of report or anything related to that of a patient, let's say X-ray or anything else, then he can have a further analysis on this page. And finally, moving on to that of the medication. So as in our case, it was Emily Garcia. So we are just entering the name, and it would be generating medication for the patient. It would be suggesting what all kind of disease which a patient might be suffering from, medication which he needs to take. And apart from that, it would be giving a five most kind of like appropriate matches for the symptoms which were been taken up from the note. And as you can see, description, symptoms, home remedies, medication, and cure has been given for this for a specific disease. And yeah, this is our about us page, and yeah, we can log out.
Okay. So what data is being used? I mean, the translation API.
Yeah.
Um,
So we web scraped the data from a Medline, which is an encyclopedia. So nearly there were 67,000 vectors which were being generated from that. And from using that data, whenever we would be giving specific symptoms from the user, it would be going through that vector space and would be generating like it would be finding out five most relevant disease and over there in the encyclopedia over like also there was all the cures and medication which a patient need to take. So all those details were been taken from them.
Okay. But I'm just trying to understand, like, how are you doing the diagnosis, or how are you using the patient interaction?
This is just an assistant to the doctor. We are not eliminating the doctor in place. This is just for the doctor, just in case he makes any error here and there, just for him to have a reference, because humans tend to make an error. So this is, like he mentioned in the before, this is just a combination of AI and humans just to make sure the healthcare system is more efficient.
I mean, I'm wondering, like, why do we need all this architecture? The goal is to just, have a bunch of services.
Professor, like it is properly been organized, and also apart like for medication purpose, as I told, the entire website was been scraped and it was been stored up into the Snowflake, and after that the vectors were being generated in order to have a proper medication for the patient.
Yeah. Okay. Oh, thanks. Okay. So this is scheme number 6, is it?
Yes. No,
Okay. So hi guys, this is group 6 and this is my name is Osborne and these are my teammates Manya, Akshita and Smiti. So our project is new scope. So before we dive into the project, I'll just tell you like why we chose this particular topic. So okay, so
how about we start with the demo?
Okay. So this is how our UI looks like with the sign up and login page. So since we've already signed up with quite a few credentials, I will use one of them.
So this will be the first landing page once the user is successfully logged in. So this is more of a customized page for the user that we're providing, starting with the top 5 news that has been that is available in the database, which is getting populated through the web scraping. So we've populated most of the news with Expander just so that to have a better UI UX for the users. So once you click on the Expander, you're gonna see the entire content along with the image if it's available. So that's one of the features. The other one is we do have incorporated adding keywords like Taylor Swift, because we have quite a lot of news about Taylor Swift because the recent concept that's going on. So I'm just gonna add Taylor Swift. So guys can see this keyword getting populated. Once I click on it, yeah, again, we're gonna have news related to Taylor Swift only and only. So we can add few other keywords like yeah, prompt is getting added. The reason why I did this to demonstrate the working of recommended headlines. So the logic behind the recommended headlines is based on the keywords. So as in when the user adds on keywords for faster retrieval of the data that they want to look into, once you click on recommended headlines, it's gonna pull out a bunch of headlines that is based on the keywords that's given by the user. So this we've incorporated using SQL similarities. So this is more of a data as a service, not a model. So next, moving on to industry newsfeed, which
so this is basically for the users that do not necessarily want to look at the content of the news. So this is filter based on the industry, and this will give out all the headlines with respect to that particular industry that has been selected. This is just for the purpose of having the headlines right there. So this is another feature that we have, which is pocket summary. This starts off by by selecting one of these industries that we have. For example, if I want sports news, I will have all these headlines stored here in this drop down, and I could select probably this. And when I click on the generate summary for the selected headline, it will give me a summary of this headline with respect to its content. So this is for the users that do not necessarily want to scroll through the whole content, and they just get a one paragraph precise summary of what is what is there in the content of that headline with respect to that industry. So this is how the summary gets generated. And we also have a button where we can clear the summary. This is again just for a better UI experience.
Next, moving on to Newsnet. So we've observed a lot of applications, especially the news platforms, having keyword-based search. So all we need to give is like how we did for the before one, like Taylor Swift or Trump or Biden, news like that. So we wanted to incorporate this so that the user can have given a natural language prompt, like give me news on Taylor Swift, give me news on Torture Poets Department, or give me a news on anything. So once you do that, we're gonna have, let me do the demo for that. Answer just going to Taylor Swift. Yeah. So here the drop-down box gets populated with the relevant headlines as per the user query. So let me choose one of those. And here you can see the content getting populated along with, here we're not doing the summarization, we're just populating the entire content along with the image if it's existing in the DB. So this is one of the feature we incorporated. Now, we've also given the logout button for, again, better UI experience, which is going to go back to the landing page. Now, Manya will talk through the architecture diagram to talk about the technical components of the project.
Okay, hi everyone. As you have already seen the demo right now, I'm going to be talking about how our data pipeline looks like for our applications. First, we're starting off by scraping different data sources. As you can see, we are doing it from CNN, CNBC, SI, Wired for industry-specific articles. And now the web scraped data, the raw data, is going to go and get stored in Snowflake, where our automation is going to kick off in the first box that you're seeing here. So the first Snowflake image that you're seeing, it has our raw scrape data, and then that is going to be pulled to DBT to be performed some data transformations, where the logic Smriti is going to be talking in detail after I finish the pipeline summary. Then after transformations, the clean data is going to be populated again on Snowflake. So this process is being automated by Airflow. Now we'll be talking about generation of article summary, which is our use case number 1. Now, I'm just going to scroll down here to show you the in detail technicality behind that pipeline. So first, the user is going to input any specific headline from the Streamlit interface, and now the Streamlit is going to interact with OpenAI model through an API key request. And OpenAI and Pinecone are gonna interact, and the vector database where the namespaces and the headlines are stored, the Pinecone is gonna give it back to OpenAI, and OpenAI is gonna give it back to Streamlit, where the output is the summary of the chosen headlines, which user wanted. Now, coming to the second use case, which is complex natural language query search, we are incorporating NLQI here, where our OpenAI model is going to do a basic English natural language prompting can be performed here in our use case number 2, where, as you can see in the pipeline here, the user is going to input any random sentence, and Streamlit is going to interact with OpenAI again via an API key request, and the retrieval of relevant headlines are going to be retrieved on the Streamlit UI interface. Coming to the last use case that we had, the customized keyword recommendation. Now that we're going to be doing by matching headlines via regex search plus scoring. So when the user gives in the keywords, the relevant headlines are going to be pulled out through this. So all of this you see right here is the technicality behind our data pipeline. I'm also going to be talking a little bit about the automation part, where, as I said, we're doing the raw web scrape data to Snowflake, then DBT transformations, then back into Snowflake for the clean transformed data, which is going to be kicked off into Pinecone for the vector embeddings. So here we're using some Python operators, we're defining some task dependencies and using like an image of our tasks. And this is our scheduled DAG. And yeah, that's pretty much it. And we've deployed it on GCP and containerized our applications via Docker. My teammates are going to be talking further on the challenges that we have encountered in doing this application.
Okay, so these are some of the challenges which we encountered. So I did the beautiful soup part, and as everyone knows that like the HTML structure is not uniform for all the websites. So that was one of the challenges which we encountered during the image collection. And I think the second will
Yeah, so the second challenge that we encountered was with respect to the NLQI, where we were processing segmented headlines with the help of AI. But one thing that we noticed was that because of the special characters and white spaces, it was quite difficult for us to get them into get it in a uniform manner. And then although we were using regex for the same, but it to an extent addressed the irregularities. Yeah, it's still
adding on to that, this thing we were able to observe in the NLQI part especially, and the reason we were not able to, still this thing exists in our application at times because this is an OpenAI response. The headline ranking comes from the OpenAI response. It's got some asterisks or hashtags that before preceding and following the headline. So because of that and the kind of match that we're doing with the Snowflake DB, because of the additional characters that exist with the OpenAI response, we're not able to perform the select query match that's going on for certain things. We did try to handle it with the regex, but again, as Akshita said, we couldn't handle every single case that's coming up. So that was one of the challenges that we faced. And moving on to how we handle the duplicates and how we are removing the data that's still existing in the backend. So that's been handled in the DBT transformation, where I've added a post hook while performing the DBT, so that so this is where I'm performing the union all from the raw data. So as you guys can see here, I'm truncating the raw data load just in order to make sure that we're not loading the same data over and over again into the final combined database. And also I'm deleting, making sure that I'm deleting the data that are 2 weeks older, just in order to make sure that the database is maintained in an efficient way, and there is no overload of data, so that it's easy for the SQL to query with the application as well. And yeah, I'm also handling the duplicates. Sorry, next thing is I'm handling incremental load, just to make sure that I'm not loading the pre-existing data that's coming from the, at times we did observe from the web scraping code that it's getting data from older records, as in like, let's say today's 26th, we did find some records from 24th or 25th from few of the sites. So I'm handling it by deleting them post hook. So we've addressed a few of these cases in the data loading itself. So yeah, that's our project. Thank you. Any questions?
I'm not understanding like the difference between like why you're scraping data and it's news, so it has to be real time.
Yeah.
I don't know what the role of your scrape data is. And, yeah, can you explain like what the rationale is? I don't understand that.
So we scrape data every single day. Morning 9 a.m. the tag will be triggered. So the initial tables that you're seeing here is in the raw news feed. That's in the raw news feed is the raw dump from different sources. And I'm performing a union all just to have it in a single table, so that can be used as a pointer from my web application. So
yeah, I mean, why do you need it again? Like, why can't you just? I mean, you have something wherein you're trying to get the keyword and trying to get news associated with that. So why don't you do it when you need it? Why do you need it already curated for the day?
No, we are not already curating for a day, so we are just keeping our data, and then on the okay, so here, for example, if he wants, if you put some keyword, okay, so then the recommend headline should only recommend the headlines related to that keyword, specific keyword.
Yeah, what are you doing here again? I don't understand what's happening.
So we just wanted to provide some sort of.
No, I understand what you want to do. What is happening here again?
So once I click on recommend headline, the backend is selecting the relevant headlines based on
Where is it
the
searching?
keyword. Based on the keywords. From our Snowflake DB, Professor.
From a Snowflake DB.
Yes, right.
And you're searching headlines with the keyword.
Yes, right. And we're populating the content that is corresponding to its headline.
Okay. Okay, so there isn't any kind of I'm a little kind of confused. Like, why do you need the GPT interface again?
So that is for summary generation. So essentially, what we were trying to do is, because the articles are unnecessarily very long.
So you're not using any RAG in here. You're just using Snowflake search.
No, this is RAG, Professor.
This is RAG. Okay.
Yes. Yeah. This and the Newsnet part, that's RAG.
Okay. Okay. So can you explain what's happening here?
So here, basically, with respect to the headlines that are within each industry, the user can just get a paragraph of the summary of the content that's within the headline. So it's easier for them to go through the headline. And also the thing that we're doing here is we are reducing the API calls by just clicking on this generate summary button. That's when the namespace gets created in the Pinecone with a vector. And from there, the summary gets generated here.
Summary of what?
Summary of the headline.
Content.
Yeah.
Summary of the
There are
article.
specific headline which we are mentioning here. So for example, select a headline to summarize. So that is the headline US government will require. So I don't want to read the whole content, right? I just want to have a brief overview of what it means, what that headline means. So we'll just give us a summary.
Based on the content.
Okay. Cool. So team 11. 7 is 11.
Hello everyone. We are Team 7. I am Hari. This is Asavari and that is Rutuja. And I'm very hungry. As I talk about this, it's food. We're going to talk about food. So when I was a kid, I used to watch my grandma writing down notes when she watches some recipes which she loves and for a quick glance. My mother used to say that more than cooking, the process of cooking, finding what to cook is more difficult. So these are the two problems that we've tried solving and we'll have a look at them. You can start with the It's okay. You can start with the link and later we'll.
So this is the front sign-in page for our app. User can log in with their Google credential, and I can use my account here.
We've implemented a OAuth authentication to pick the user's email address and his name, which we'll be using to match his records with.
So once the user is authenticated, it will show user's info, like my name is Asavi Karam and this is my email address. And next part is we have added like here user can enter the URL that of the recipe that he liked, but he did not have time. So he just want to save that URL for the future use. So I'll just search for the YouTube video.
So how this happens is we pick a video which we love and that is pushed into a queue. And once it's on the queue, user can there are two ways of pushing it in. One is through our website and the other one is through an extension. So that was what Asavari was trying to download and install on the system. So through that, we push the link onto a Kafka queue. And from there, it picks up the audio from the YouTube video. It converts it into a transcript, and that transcript is converted into a standard recipe format. And we store it on Snowflake.
You're in hallway. Meet Citizens Fast Line and get a home equity line of credit offer in 3 minutes. 2 weeks later, you're funding your team extent.
I could hear was there on this page. Thanks. So this is the process video URL page where user can submit the URL that he liked, but he did not have time. So he will watch later. So I can just hit the enter and this will go to Kafka queue and which will generate a summarized recipe for that same URL. Currently, we have few recipes that I have liked and I have just loaded one more recipe which will be present there after 1 minute or 2 minutes. So this next part is find recipe, which will be explained by Rutuja.
What happened with the YouTube I list the whole part? Like what?
So Professor,
to skip and then.
yeah, Professor, it will be viewed in a favorite recipe. It takes some time. So till then, I'll show you the recommendation system we created. So suppose I want to have a high protein diet.
So here you can give inputs like high protein, the ingredients which you have, something like diabetic friendly.
And maybe for your breakfast.
And one interesting thing was Jain and Chinese. There was a fusion. That was very interesting.
So it will generate a recommendation for the recipes. So it has generated a high protein chickpea potato. It will give you three recommendations, and it will have all the details related to that recipe. Like what's the total time? If YouTube link present, then it will also mention that. And ingredients instructions. Similarly, for the second recipe it has done, and the third recipe. Yeah. Then we have also, okay, one more combination you wanted to show, and this.
You can try something. You try vegan.
Vegan, and I would prefer Chinese. Still it will, I think. Yeah, so still it suggests you some recipes. And there's a third feature. So there are total 4 features. One, the Asawari showed for the process video URL, which I'll be showing, she'll be showing the output of it. And the second one is this recommendation one. And the third one is the filters. So we scraped over 9,000 recipes from Archana's Kitchen and Ranveer Bra's website. And here if I say I want to have pav bhaji, and maybe in 50 minutes, I just do apply filters. It's just filtering the data. So these are filters. This is recommendation. And here is the favorite recipe. Yeah. So this is the URL we submitted previously. So this has generated the formatted recipe in the recipe format. So it has link for that video plus summary, and then detailed instructions that user can follow. And we have also generated tags for it. So another thing we have done is we have created a Chrome extension where if user don't want to submit URL through website, then he can also do it through Chrome extension. So I'll just load.
Meanwhile, one interesting thing which we had was finding a good match. For that, we scraped data. It was all in multiple columns. So first, we thought like, okay, if it is in different namespaces, how do we rank them according to the best matches? Because there are so many fields, and it's going to come in natural language. So then what we did was, we wrote all of that in a natural sentence format, saying like, this is the title, this is my recipe, these are the ingredients, and we vectorized it and put it on Pinecone database. Now, with this, we tried with the natural, normal conversation which we get from the user, that we tried matching with the indices, but that didn't work well. Then what we did, we took that input which the user is given, converted into the fields which we are looking for according to our format in the database. There are multiple fields like, again, the cooking time, ingredients. So we prompted GPT into a specific format, took those, and we filled it into the actual form, how we inserted the data originally. So with that, we got very good results compared to how it was built.
So we have installed Chrome extension. Here also you can use your Google account, user ID and password, and log in. Once you're authenticated, Once you are authenticated, then you can submit another URL like I want to save this URL for the future use. Then I can do it through Chrome extension as well. So here I will put the URL and then submit. So here you can see URL is put on queue, so we can view it later in the Streamlit app. So it will take around 1 or 2 minutes to show in this page, that is favorite recipe.
Meanwhile, we could go over the
Yeah, meanwhile we can go through the architecture. No, that's-
Also, the video summarization, we tested on different language videos like Marathi, Tamil, and Hindi. So it works for those as well.
So here we have the input style which we have. One is through the Chrome extension. We can pass in the YouTube video. We could also do it through the front end. And we have the authentication through Google Auth. All of this user data, we are going to save it on Snowflake on a table. Here, as soon as the URL is submitted, it goes on the Kafka queue. This we've done to reduce the load on the web servers. After that, it converts the video into audio to text using Whisper. And from there, it translates into a proper recipe format using GPT. All of this data, we again put it on Snowflake. We have the Airflow pipeline for scraping the recipes from the websites. We again put it on Snowflake. We also have validation for the format of the recipes. And we also embed it and store it on Pinecone. Yeah, so this is the overview. We even wrote CI to test the Python syntax and also for the Docker Compose validity.
And we also had test cases for fast API.
Yeah. So for the second recipe that I submitted the URL, that is lemonade cake recipe, it has generated the recipe for summarized recipe for the user. Thank you.
I mean, like the source of the data, it's primarily YouTube videos, is it?
No, Professor. We scrape the data from two websites. YouTube video is for the user to have it like notes. So primary source is Chef Ranveer Brar and Archana Sati. So these are the two primary sources.
So I'm a little confused. So you take the recipes from there, but then what is the YouTube giving you again?
YouTube is for its notes. So instead of him like going through them again, it can be a reference for it. So that is one. The second thing, which the scraping is for him to ask in natural language if he gives prompts. So to find the best recipes, we have our own database from which we fetch the recipes and give it.
Okay. I'm so confused. What is the YouTube doing again? Like what is the summarization? Like what are you trying to do?
So if we are in a hurry and we don't have time to watch whole video, so we can just get the URL and then submit.
That doesn't have anything to do with the scrape data, is it?
No.
Scrape data is for recommendation. It's another feature. The YouTube video link which we put was the Chrome extension feature where user can just submit the URL and under his profile that URL will be stored and the further it will go to Kafka queue and generate the summarization for that particular submitted URL. And that could be like, suppose I want to know what a certain Tamil recipe and I don't know the language, so I just cannot watch the video. So I can just put the link into that Chrome extension and it will translate and give me the summarization of recipe in English. So that's how it helps.
Okay. Oh, thanks. Last but not least. Okay.
Hi everyone, we're Team Age. That's Mahesh, Pujita, and I'm Shivani. And we bring to you a personal assistant called MarketMind, which will help you make decisions easier. It's not just for selecting components, but it brings you a personalized view of the products that we endlessly scroll through sometimes. It also helps us make decisions out of the products that we kind of shortlisted. And it's also, this application is also accessible for the visually impaired or people with auditory, who prefer auditory learning. I will now hand it over to Mahesh for the demo.
Hi everyone. This is our MarketMind app. I'll be. This is a sign up page where user will take user can register here.
You better speak a little louder, please.
Sure. This is a sign up page where user can actually register for our MarketMind. We're taking the username, password, and gender of the user and some of the activities that he prefer doing. And you can just sign up. We'll just log in with my account we created for the demo. So we're demonstrating the four different features, four different pages that we have designed. So we'll be going over one by one. The first thing is searching, where user can search for some of the products. So I'll just type something that I'm interested in. So it will give us the results for what I'm looking for, along with some audio where we can
Rugged carpenter style
description of the product, and then user can wishlist them as well, and user can also click for show more and get the more.
Again, can you speak a little louder, please?
Sure. User can wishlist some products and can listen to the description of the product and can load more from the same category, so from the same search results. So that is one thing, and I'll try one more search to demonstrate the new thing. So show complete outfit for let's say I'm going to gym and I'll need some outfit. So I'll ask for show complete outfit for gym. Let us see what it's going to give me for going to the gym, which I needed. Yeah. So these are some things that we needed to go to gym: leggings, gym workout pants, and loading more shorts and the tank top. So as we are seeing, we are having different sections which completes the outfit for gym, leggings, and the actual tank top and moving on training shoes. So it runs chain of things, and it gives all the things that we need to have for going to gym, socks and everything. So it completes the outfit with a single search query that needs for going to gym. And I can also try with for going to party. If I'm going to party, I can search for one more thing before moving on to the next functionality. Yeah. Meanwhile, I can actually download one of the image that I can use to search for image as well. So if I'm going for some party, it's giving me some black suit here and white shirts that is on top, like leather shoes that complements the white shirt and suits basically, and wristwatch that can go well with suits and other stuff. So yeah, it's still loading some of the things. Yeah, that's for party it has. So these are some things that completes outfit for party. It's not only giving the products from different sections, but it's also making up the queries that can actually use to search from the embeddings, the descriptions. That's for the search, and I can even search with the image something. So I can actually just do this. This is some of the IP issues that I run into, and so I'll be downloading the image to upload it here. I'm just typing show products like this for going to gym. So it identified that I'm looking for something Nike product and dark gray gym shoes. So it is showing the relevant results by observing the thing, and also searches for more category, I mean more brands or more categories in the same with the same specified description. Yeah, these are some products that we got in search page. So once we add them to user wish list, so there is something happening here. Which can actually help us finding the right products. So these are something I already added into my wish list, jeans and a different type of shirts. And I'll just ask some of the queries here. Who is that explaining more?
So I'll just quickly navigate through the wish list interface out here. So like you have seen that there was an option in the search functionality where you can wish list the products, and also you can get to see the audio functionality of the search of the products. I mean, the summaries can be visually heard, right? So over here in the wish list, you get to see all the products that we have wish listed before. And that is to the left section, and to the right section, we tried something unique out here. So this right section will will act like a chat system, wherein you can ask the bot where like what products would go well with the wish listed products that you have already have in the cart. So if I just say that for now, like Mahesh is just giving an input saying what will go well with the pants that the Wrangler men's rugged carpenter jeans, and which shirt will go well with that. So once I've hit that, like then over here you get to see that this shirt is actually going well with that particular pant for the hiking purpose. So even you have a summary out here in the bot where it says for hiking, I do recommend so and so shirts because it is more comfortable for the functionality for outdoor activities out there. So that is how we're trying to get the best fit for a particular outfit. It just acts like a personal fashion diary for you. It will help you match your right products, and it will help get your current outfit for any event that is possible. I mean, for your convenience, like whether it be for party or hiking or anything else. So let's change the output again. Let's this time try, since previously we have given it for the hiking purpose, let's try and give it for a party maybe this time. So we'll try which shirt will go well with that particular jeans in a party. So we're getting a formal shirt, right? This matching is done within the wish list itself. So this product, you might have wish listed a couple of products in your cart, right? So when we're trying to match the products that go well with each other, we're trying to pick these pairs are from the wish listed cart itself. So also you have a delete option whenever you want to remove something from the wish list. You can just click on delete and you can remove that from the cart. And this chart system is something unique that we tried embedded in this wish list section so that you can match your outfits together whenever you want to go to any place.
We also have the reviews functionality based on the reviews the data of reviews that we've used. We can ask our chatbot to tell us the quality of the product or what the previous users have really done. Said about this, and we'll get a short summary to make a decision and make an informed decision basically and come to the right choice.
So like just extending to what Shivani said, we just gave an input saying, is this jeans true to its size? So the user might want to have an analysis like if he can actually go with it or go to the next size, right? So such questions will also be given appropriately by the bot, and these outputs are usually given by the summarization of the user reviews. So we are giving all these outputs by taking the summarization of user reviews from our data set.
And going on to the next section, which is the personal recommendations for the products that you might like. Over here, if you can go to the top, please. So this section, you can see your favorite pastime activities, right? So these are the activities that you have selected while you have been given, while you were trying to sign up to the application. So those activities will be reflected out there and also to the top. Also, these recommended products are usually given based on your search history in the search interface that has been shown previously by Mahesh, and also the activities that you have chosen during the sign-up process. So that way, we're consolidating all these inputs and then giving you a recommendation. And see over here, you can see various products that have been categorized according to the products, like let it be watches, shoes, or the clothing. So we just try to give the top 5 activities that you might like. And if in case you want to refresh the recommendations, you can just go ahead and click refresh recommendations. So get a new set of products that you might like. These are all according to your interests. So finally, search by image will be.
Thanks, Pujita. The last functionality that we'd like to show is search by image. Sometimes we come across products that we don't know where they're from, and we would really like to find out more about those, so we can directly upload any image onto the system, and it will fetch data about that product directly. So it will again give us more information about the kind of product that we are seeking to buy, so that the consumer can finally make an informed decision.
So here we're just trying to upload the image. We're not giving any text out here. We're just trying to upload the image, and it will give some relevant products that you might like.
That's the product that we have built, and behind the scenes, we have used Airflow to orchestrate the different DAGs which we use to populate the data that we are seeing in the platform. So different DAGs we built for summarizing the product description and uploading them to Pinecone for finding the right results, and the detailed descriptions and detailed features are being stored in Snowflake as well. And as well as for the summaries, we chunk the summaries and summarize them over the batches, and then upload them to Pinecone and then use them to answer the queries of user in the bot. And that's the 2 different pipelines that we use. And the images also, we embedded the images and uploaded them to the Pinecone in different namespace to get the direct similarity matches when user upload image without any text description. That is one. That's the architecture diagram, and the different parts of code. And we have written the tests, unit tests and integration tests using PyTest. And then implemented CI/CD to build to run the tests, and if tests are successful, we're deploying them through the GitHub Actions directly using the SSH and storing the secrets in GitHub, and then we are uploading them to the we are then deploying them to AWS EC2.
Thank you.
So, with respect to data, did you use Clip or was it just embedding on the images?
Images we used the Clip to embed for the product images that we have.
And I'm just trying to understand, like, are they like multiple use cases, or are they all connected together?
Connected together, basically. So
connected together as in like not just the integration in the Streamlit, but like are they all having their own databases and they're all doing their own thing, or what exactly happening? Like I'm trying to understand like the data pipeline and how those services are connected to the data pipeline.
So we have the single source of truth, the Amazon reviews and Amazon metadata set, and from there we bought the products. And for the products, we did summarization and store them to Pinecone. And for the same products, we extracted the reviews and built them and uploaded them to Pinecone and Snowflake respectively. So it's the same products. Products are the key thing. And for the products, we extracted the reviews from the data set and then chunked them and embedded them.
Okay. And the reviews, when you ask like the questions and stuff, I didn't understand like the recommendation keys.
The suggested products is basically using the previous 5 user searches and the activities that they like, and generating the product descriptions that he might like using the help of GenAI. And we are searching the product descriptions that it generated over the pine cone and getting the products to them.
But where is the repository of products which are available?
The whole products.
This is just generating products from the internet or?
No, from the existing DB that we have built over Snowflake. Nothing is live actually. I mean, we processed all products and uploaded them to the Snowflake and.
What's the recommendation algorithm? I didn't get that part.
Last 5 searches of the user as well as the sign up activities and generating the product descriptions that user might like.
What are you using to generate the? I mean, like you give the input is the search.
Yeah.
And what is the output? Like how are you?
Product descriptions will be getting from the OpenAI API. It will give us.
What are you passing to OpenAI and what are you getting back?
So we are passing the last 5 user searches, favorite activities that user might like. So we're tuning them to give the 5 descriptions.
I understand that 2 parts. Like you're prompting it by saying here are like the favorite activities, here is the search. But what else are you providing?
For finding, I mean, once we get the description from the GenAI, we are.
What do you mean by description from GenAI?
So these workout tank tops for men.
Where is that coming from?
GenAI will be giving them based on the user search.
I'm asking, is it coming from ChatGPT or is it coming from your RAG?
It's coming from ChatGPT.
Okay.
Yeah.
But so that's my question. Like, so is this just to generate internet products or is it? You said it from your curators.
Yeah, from my curator. So once I got this thing, I'll be searching them against the pine cone and get the right products as identifiers and get the details.
So you are getting the text from.
Yeah, that search.
Okay. Okay. I think I get what you're saying. Okay.
Yeah.
Okay. Cool. Okay. Thanks, Greg. Okay, so that was much faster than I expected. You know, it's still at 9 o'clock. We still technically have half an hour more to spend. But you know, really good presentations. It's always nice to kind of see what you have taken, assimilated, and use your creative sense to build out new products. I mean, that's kind of the goal, right? So you are trying to understand what are the capabilities and trying to use your own ingenuity and your own creativity to make it your own. That's why the final project is something I let you guys decide rather than me giving you the specifications saying you gotta do X, Y, Z. Okay. Now we have the hard task because we gotta spend some time over the weekend trying to get the grading for your final projects done and making sure that we submit your grades on Monday. But please keep your systems up and running. I want to make sure that when we click on it, it actually works. And secondly, I also want to make sure that all the test cases you have are actually accessible. So we want to make sure that we can run through those. Okay. But overall, I think you guys did a good job. And now the question is, how are you going to take this and market it? Because in many ways, marketing is a skill. And when you pitch these to potential employers or whatever your goal is, creating a new company with a new product which you got an idea for from this class, or going for an internship or pitching this as a project for your potential employer for your full-time position. It's all left for you to define what they call as the elevator pitch, right? Because you can't discuss all the technical details and go into the nitty-gritty of why you did what you did. So you've got to focus on what is the major theme of what you worked on and how were you able to accomplish that particular goal. And in that particular realm, there are so many things you can focus on, and that depends on what you actually accomplish. I mean, is it the data part when you had to process a lot of data? Or is it the integration part wherein you had to work with multiple components and build out enterprise architectures? Is it the scalability part wherein you had to leverage cloud and CI/CD and various things which you could potentially use to build out your entire pipeline? So all those are different themes, right? So one is the data engineering side, another one is the application integration and the application engineering side. One aspect is the DevOps, the MLOps side of the story. Some aspects could be just analysis, how you are analyzing the data. It all depends on what side of your persona you're going to portray. And that needs to be aligned with what you intend to do in the future. Right, so if your position requires you to be really good with working with different kinds of data sets, then you can pick apart that part of that project we worked on and figure out like how you were able to use the data integration, the data extraction, the data engineering side of skills to build out your entire architecture. So you can introduce the architecture and then say, this is where we actually had to do all these kinds of things. So the more you understand what you actually did, rather than just saying, close the book and we're done for the semester, the more you will be in a position to articulate what the problem was and how you were able to accomplish it. I mean, everybody has their own way of dealing with things. Some of you focused on the front end, some of you focused on the data part, and I'm pretty sure everybody would have had technical challenges. It's not like, everybody got it on the first time. You were looking at multiple APIs, documentation, all the good stuff. But honestly, no one really cares when you are kind of positioning a solution on the challenges which you faced, right? And if you don't, kind of portray the challenges in the light of why you had to do all these things, it just becomes another set of sob stories. Like, I had to wake up all night and I found this bug and I fixed it. Like, yeah, you are able to do that, but what are you trying to sell at that point, right? But if you are talking about like, well, this is the volume of the data, if this is the amount of data, this is the variety of the data, and you had to assimilate the whole thing, put it into a particular format, and in order to do that, you had to learn new things or try out new methodologies or use very specific methods. Then there is this problem solution, and whether your solution was creative, whether you were methodical in terms of coming with a solution, or you have done so many similar projects wherein you were the person to solve that particular problem, kind of positions you to whatever position you are going to be applying, right? So these project portfolios are things which you gave a pitch today, in a 10-minute pitch, and that pitch needs to be whole. It's not like the first time and the last time you give a presentation and you're done with that. And you may want to think about, because when I interview people, I usually see a lot of group projects and people usually present group projects, but then they forget to kind of make it what part of the 2 or 3 weeks you did and why was it critical to the whole thing. So that piece typically gets missed out. You have to talk about the project, but when you talk about like why you did actually certain things and how you designed it, how were you integrating things, how were you able to work in a team? So all those are lessons you have learned. So be able to articulate that, and hopefully that will help you kind of realize the dreams. Many of you have kind of flown thousands of miles to come in here to learn these skills, but it's now what you do with what you have, and what you will be doing with all the knowledge you have is going to determine the trajectory of where you're going to go. Okay, so it's a pleasure working with you all. Thanks for making a Friday and a Saturday class. Those are the only times I can make, but you kind of worked all the rest of the week and took your weekends off to attend this class, and hopefully it was helpful. And wish you all the best. Okay? Thank you.